Okay, so if you've completed the derivatives unit in calculus, here is a chapter test, part of the Calculus of First Course textbook, and this is on page 115. So this would be a good test to try before you did a unit test. So the very first question on page 115 was asking for the definition of the derivative of f prime as a limit. This is just showing that we know that if we want to find f prime of x, we can use what came from the tangent line of finding the slope, which is as your limit as h tends towards 0, you have f of x plus h minus f of x, that's an x, sorry, all over h. And we're making that h value get smaller and smaller, so we see that limit almost in an instant. So now using that derivative, we want to be able to find the following, or using that definition. So for this one, even though we do now know shortcuts, we want to still be able to show that we know how to use essentially the formula to find the derivative. So if I want to figure out the limit, or f prime, as my limit tends towards 0, I would have f of x plus h, so I'm just going straight to filling it in. So I'd have x plus h squared minus 7 times x plus h plus 4, and then subtract f of x, which is just that whole thing. So x squared minus 7x plus 4, and this is all over h. We will notice that we can expand out the numerator. So just expanding that out, we would get x squared plus 2xh plus h squared, and then continue to expand, minus 7x minus 7 times h plus 4, and then distributing that negative through the bracket, minus x squared plus 7x minus 4, and this is all over h. So we'll start to see some things canceling nicely, like your x squared terms, your 7x, your 4, and then from the first 3 terms, we can take out an h. So if I took out an h, I'm left with 2x plus h minus 7 all over h. And now our h's cancel. And if you plug in your limit now when h tends towards 0, then you would know that f prime of x equals 2x minus 7. So that is our first answer after doing all of that work. And the second part of this question is just finding the derivative when you're dividing. So we're doing the same thing. If you wanted f prime of x as h tends towards 0, we would have 1 over 2 times x plus h, and then we subtract 1 over 2x plus 1, and then this is all over h. So for this question, we would simplify the numerator by getting that common denominator, and so you would end up having here 2x plus 1 times, which one am I doing here? Sorry. Am I missing a squared? Oh, I see what I'm missing. I'm missing the plus 1 here. Okay, so what I have here, let's just do this one more time, is just expanding out first. So I'm actually, before I do that, so what I was missing was just that plus 1 at the end of my first one. So what I'm going to do is just expand out that bottom part. So I have 1 over 2x plus 2h plus 1, and then minus 1 over 2x plus 1, and this is all over h. Now I'll actually simplify the numerator, and my lowest common denominator would be just essentially all of that together. So 2x plus 2h plus 1 times 2x plus 1, and then I would have from there taking this first part, multiplying it by 1, the second part, multiplying it by the negative 1, and I would end up getting 2x plus 1 subtracted 2x plus 2h plus 1, and this is all over h. So then we can simplify the numerator a little further. The 2x's would cancel, the 1's would cancel, and then we'd have negative h, negative 2h in the numerator, and then still all of that in the denominator, 2x plus 2h plus 1 times 2x plus 1. And then if I'm dividing by h, it would be like h over 1. So I can now multiply by my reciprocal, and I can see my h canceling. And now I could also plug in my limit when h is 0, and that term would go away. And all of this would end up simplifying to negative 2 over 2x plus 1 squared. So we do have that very long way to find our derivatives, and it's nice that the next part we start to use our shortcut. So in question 2, you're starting to use all of your rules. So that first one, 2a, if we're finding the derivative, you are just using your power rule. So I would rewrite this as x to the power of 3 over 2, and then figure out f prime by using that power rule, bringing 3 over 2 down, multiplying it by x, and then subtracting 1 from the exponent, and you would get negative 1 over 3. And then if you take a look, oops, what am I missing here? Oh, it was, sorry, this was opposite here. Just, it would be 2 over 3. And so this needs to be 2 over 3. This exponent was still right. And then the last thing here is to write it with a positive exponent. So this would just be 2 over 3 times the cube root of x. So that's our first derivative, just using the power rule. The second derivative, which we're calculating in B, is using your quotient rule. So when you're looking at your quotient rule, you take the denominator, so just as it is, so 2x minus 1, and multiply it by the derivative of the numerator, which is just 2x. Then you subtract your numerator, just as it is, so x squared plus 3, and multiply it by the derivative of the denominator, which is 2. Then this is all over the derivative, sorry, not the derivative, the denominator, but that's squared. So that's as far as we can take it, but what we can also add or just simplify is the numerator. So if we simplify the numerator, we'd have 4x squared minus 2x minus x squared. Oh, actually, let's distribute that 2 one time. So minus 2x squared minus 6. And then we can just collect some like terms right here. So that would end up being 2x squared minus 2x minus 6 all over 2x minus 1 squared, since that was still there in the denominator. So that's our f prime using that quotient rule. Our next example is using the product rule with the chain rule. So if I'm looking at C here and I'm finding f prime of x, so the product rule, we are starting with the derivative of your first term or first binomial. So 4 times x squared minus 1, and then you multiply it, because it is the derivative, with the chain rule. So multiply it by the derivative of the inside. So I also had to subtract 1 from the exponent. So that is 2. Then I multiply it by the second binomial, which is 2x plus 1, all cubed. Now I add on the derivative of the second binomial, so 3 times 2x plus 1, using the chain rule, multiply that by the derivative of the inside, and then multiplying it by, I keep forgetting to take away one exponent, and then I multiply it by the original term of the first binomial. So that's my setup, and then I need to simplify. So from here, I can see that I could take out a 2. I can take out a x squared minus 1 to the power of 3. I can also take out a 2x plus 1 to the power of 2. When I do that, I'm left with a 4 from my first one. So essentially this all cancels, this cancels, and 2 out of the 3 cancel. So I'm left with 4 times 2x plus 1. And then from my second part here, so plus, I would have 2x, all of this go away, the 2, and then 3 out of the 4 here. So I'm left with 3 times x squared minus 1. So I want to simplify what's in here. So I'm just going to rewrite again what I have first. So 2 times x squared minus 1 cubed times 2x plus 1 squared. And then from here, we're going to do some distributing. So we'll have times 8 x plus 4 plus 3x squared, and then minus 3. And I realized I did this earlier as well. When I did the chain rule, so going back, and you probably caught this already, but I didn't want to rewrite the whole thing. But when I do the chain rule here, my derivative of the inside is actually 2x. So instead of just having a 2 left over, I do have a 2x. So just coming back over here, I would have had an x here, which would give me 8x squared plus 4x. Sorry about missing that. And now that I have everything exactly how I needed it, now I can collect like terms one more time. So just some like terms here. So I still have that 2 times x squared minus 1 times 3 times 2x plus 1 squared times 11x squared plus 4x minus 3. So I actually, when I did this practice test, I missed that earlier. So I really have to watch out for that when I'm taking the inside derivative. And so we did all that work, and now we have the derivative of c, which is the product rule and the chain rule. The very last one here, so I'm just going to erase all of this. So I have room here. And if I'm looking at D, and I'm doing the same idea, I have the product, or the power rule that I have to do first, and then I'm going to have to use the chain rule. So I'll have 7 times x plus the root of x to the power 4 minus 2x plus 1, and then subtract 1 from the exponent, which is 6. And now I have to multiply by the derivative of the inside. So the derivative of x by itself is just 1. And then if I rewrote that as an exponent, it would be 1/2. And then I would multiply that by what we have within x4 minus 2x plus 1. And then I'd have to subtract 1 from the exponent, which is negative 1/2. And I also still need the chain rule and multiply by the derivative of what's under the root, which is 4x to the power 3 minus 2. So we do all of that work, and that would be our answer. If you did see this written under the root sign, it's just making that, or in the denominator, it would just be to make that exponent positive. But that is what we're doing there. So power rule with chain rule. The next part is, I did have another slide there for that. Okay, so the next part is looking at curve with the equation 3xy equals x cubed plus y cubed. If we want to find dy over dx, that just means we're taking the derivative. So the reminder that if we're doing that, we're taking the derivative of 3xy over dx, and that would equal the derivative of x cubed over dx plus the derivative of y cubed over dy. Now, this part here, because you have 3x times y, if to take the derivative, you do have to use the product rule. So taking the derivative, we would start with 3x times the derivative of y, which is just dy over dx. Then we would add on the value of y by itself times the derivative of 3x, which would be 3 times dx over dx. And then that would equal, moving to the other side, the derivative of x cubed, which is 3x squared dx over dx. And we'd add on the derivative of 3y, which is 3y squared, and then dy over dx. So reminding ourselves that if you have anything divided by itself, it just equals 1. So those ones would go away. And then you want to collect your dy over dx to one side and everything else to the other. So if I did that coming up here, sorry about that. If I came up here and again did that again, I have 3x dy over dx. I'll move this one to the other side by subtracting it. So minus 3y squared dy over dx. That will equal the 3x squared. And then I will move the 3y to the other side. So minus 3y. Now I have this common term of dy over dx that I can take out. Dy over dx. And when I do that, I'm left with 3x minus 3y squared. and that all equals 3x squared minus 3y. And I'll just divide that over so that dy over dx is alone. So dy over dx will equal 3x squared minus 3y divided by 3x minus 3y squared. Noticing that we do have a factor of 3 that we could cancel out. So if I factored a 3 out of the top and out of the denominator, all my 3's would cancel. So dy over dx, running out of room here, will equal x squared minus y over x minus y squared. So we did all of that work, and what we want to recognize, what we found here in A, would be the slope. So I'm going to do the same thing and just erase the work, just so I have a bit of room. And now that I have my slope at the bottom there, after all of that work using that differentiation, again, recognize that the derivative is your slope. And if I want the equation of the tangent line, then I can use the formula y minus y1 equals your slope times x minus x1, where this is the point we're going to plug in. So we need to know the slope at x and y, so we're going to replace 2 over 3 in for x and 4 over 3 in for y. When we do that, we will find out that our slope equals, where am I looking here? It ends up simplifying to 4 over 5. So now that I have that, I can go to my slope point formula, plug in my y value, plug in my simplified slope, and plug in my x value, which is 2 over 3. Then I want to get rid of the fraction, expand out, and bring everything over to one side. And when I do that, I get 12x minus 15y plus 12, and that all equals 0. And we could see there's a factor of 3 there that we could take out and reduce that by, but we also have an equivalent equation here. Number 4 is showing that you can still take other derivatives. So if we wanted to figure out the third derivative of what we have, what I would start with, if I want y prime, I would rewrite this so that we don't have the exponent in the denominator, so like we don't have a division there. So I would rewrite this as 3 minus 2x to the negative 2. Now if I took the first derivative using the power rule, I would have negative 2 times 3 minus 2x, subtract 1 from the exponent is negative 3, and then multiply by the derivative of the inside, which is negative 2. So this simplifies to 4 times 3 minus 2x to the power of negative 3. Now if I want the second derivative, I am using the power rule again. So bringing that negative 3, multiplying it by 4 to give you negative 12. Then 3 minus 2x is still there. Subtract 1 from the exponent, and then multiply by the derivative of the inside. This simplifies to 24 times 3 minus 2x to the power of negative 4. Now, seeing the pattern here, doing this one more time, taking the negative 4, timesing it by 24 is negative 96, and that's times 3 minus 2x. Subtract 1 from the exponent, negative 5, multiply by negative 2. This ends up being 192 in the numerator, and then we can put 3 minus 2x to the power of positive 5 in the denominator so that our exponent is positive. Moving on to our next one, and I believe we're almost done here. We had 2 more questions on this practice test. So this one is asking us to find the point on the curve of y equals the root of 2x minus 1, where the tangent line is parallel to the line x minus 3y equals 16. So what we want to do here first is, if we're looking at that tangent line, we do need to figure out the slope of y equals 2x minus 1. So we are going to figure out y prime. So if this was our exponent, it would be to the power of a half. So we'll take that half, bring it down, and then I have 2x minus 1 to the power of negative a half times 2. Doing that, we'll see that those 2's cancel. So your first part here is 1 over the root of 2x minus 1. Now, if our tangent line is parallel to this line given here, parallel means your slope will be the same. So the slope of our tangent line will be the same slope of this line here. So if we rearrange this to be in y equals mx plus b form, then we know the number in front of the m is the slope. So I'm just going to do that. So I'll have negative 3y equals negative x plus 16, and then we divide both sides by negative 3. So the number in front of the x would be 1 over 3. So now if our slopes are the same, we can set them equal to each other. So we can take 1 over the root of 2x minus 1 and set that equal to 1 over 3, and then solve for x. So let's do that. We'll get 3 times the root of 2x. Nope, that's not right. We'll get 3 equals the root of 2x plus 1. Square both sides, you'll get 9 equals 2x plus 1. And then solve for x. Move the 1 over, divide by 2. X will equal 5. Now that we know what x equals, if it's on our line over here, we're going to plug that in to find y. So y will equal the root of 2 times 5 minus 1, which is the root of 9, which is 3. So our point that is on the curve and parallel will be 5 and 3. Now our very last question is to differentiate the following. And it gets a little bit confusing when we have like the function embedded into another function, but it's still essentially the same thing. So for instance, with that first one, if I want to find g prime of x, I would take the derivative of all of f of x to the power of 6, and then I'd have to use a chain rule and multiply by the derivative of the inside. So that would be my first answer. Looking at the second one, which is b, it is very similar, except this time I would need to take the derivative of the first part. So just h of x, looking at prime, would equal 6 times f of x to the power of 5, and then we would multiply it by the derivative of the inside. And then this last one would be using the quotient rule. And so if I wanted to find f prime of x, it would equal, and our quotient rule, you take your denominator, multiply it by the derivative of the numerator, subtract the numerator times the derivative of the denominator, and divide by the denominator squared. So that is the end of the chapter test. I hope you found this helpful, and if you do write a derivatives test soon, I hope you do well on it. If you did find this helpful, please subscribe. If there's any other video I can do for you, let me know. If you're taking chemistry, please check out my channel and my website. I hope you'll find it helpful. Thanks for watching.